mentioned that TEI will produce TFX engine in up to 10 to 15 years. What is your time schedule for that? What is your expectations?
Actually, this statement came after our own internal study about whether we can do this engine, 35,000 pound thrust class engine, which will be capable of giving the ability to a TFX fighter, the fifth generation abilities in terms of super cruise, low IR detectability, etc. So our team internally studied about the limitations and our technological capabilities, and studied the design alternatives, different compressor pressure ratios, stages, number of stages, turbine number of stages, etc. And as a result of our own engineering studies and alternative scenarios, we have seen that as TEI, we are capable of developing such an engine, 35,000 pound class engine, including the fifth generation requirements, aircraft requirements, such as IR suppression or sufficient thrust to give the aircraft ability for super cruise, which means without afterburner operation, giving the aircraft supersonic cruise capability. So we studied all of these, and as TEI, we are confident that we can develop such an engine. And our internal studies show that it may take 10 to 15 years for us to develop such an engine. Of course, if we collaborate to develop some parts of the engine, like, for example, afterburner or thrust vectoring nozzle, if someone else, we get help from someone else and they do it, and we integrate it to our core engine, it will be, of course, reduce the development time.
The thrust vectoring you did not mention, is it included in your calculations?
Yes, we have to develop capabilities, new capabilities for such new technologies. Up to now we didn't do it, but we studied the requirements and technical challenges. We feel confident that we can do it, but of course it will take some time to develop and test it.
And the Turkish delegation headed by the President of Defense Industries was recently in United Kingdom. They met Rolls-Royce and other companies. So they are also working for a cooperation on TFX engine. What do you think about this option?
Actually, of course, we do not know how this development work will be configured by SSP, Presidency of Defense Industries, or whom they will give the task, or whether they will form a multi-national team or not. But we study our own capabilities, and that's what I am saying right now. But as TEI, we are the biggest and the most capable aircraft engine company in Turkey. And beyond the engineering team and engineering technology capability, we also have the most capable infrastructure in terms of producing such an engine, 35,000 pound thrust level engine, and instrumenting and testing such an engine. We have test capabilities up to 100,000 pound thrust class, so it will not be a problem for TEI to develop and test such an engine. In terms of manufacturing also, we have all the capabilities. As a result, no matter how the development team and configuration results, in the end, in terms of production, will be in Turkey. And STI, we feel that no matter what, we will be within this development team, at least in the manufacturing part, it should be done in TI.
And if it is done so, what would you expect from other companies? Because working together could be working on one subject together or dividing the subjects, and one side works on one thing, other side works on something, and all is united at one place. What is your expectation here?
Actually, if a design team is fragmented, I mean different institutions are working on the same design, there will be some difficulties, of course. It may speed up, in one aspect, it may speed up the development time because different teams are working on different parts of the engine. But at the same time, it may cause integration problems, which may cost additional time, plus communication problems and other stuff. Therefore, our feeling is that the core engine, what we call core engine, the compressor, combustor, and turbine as a whole should be done within the one design team, which we feel that it should be done TI. But an afterburner, low power turbine, or fan upfront, thrust vectoring nozzle, and accessories, all these other parts and modules can be done in different teams, which may only add up to the core engine and speed up the process.
Turkish delegation talks about the TFX engine, but United Kingdom is also working on their own aircraft, Tempest. So would you expect to be in that work as well?
As TI, I feel that first we have to develop our own national TFX engine. Once we have the capability and we develop the capability and demonstrate it, and of course we may expect as requests come from different nations to participate in their own national engine programs, depending on how Turkish government looks at the issue, of course we can work with different teams.
Now we are in Azerbaijan at the booth, TEI booth. I see TEI PG50S, an engine.
Yes.
And formerly we have seen that you produce a same engine without S. What is the difference between S and without S?
Okay, actually PG50 engine, as the name implies, it's a gasoline piston type engine to deliver about 50 horsepower. Initially, it has been developed as a limited life engine, but we have seen in the market there is a need for the growing drone market as the drones get bigger and heavier and their mission times increasing. We have seen that they are going to need fossil fuel powered engines because of the battery size and the time weight issues. As the drones get bigger, mission times get longer. The electric typical classical drones which are powered by electric battery power, they will be limited. So sooner or later we expected that they are going to need, in this power range, they are going to need fossil fuel powered engines. So PG50S is like a superior engine in terms of extended life, long life engine, which can be used multiple times, a longer period in typical drone applications.
So you see a deadlock at the engine, electric engine, on this specific class. That's why you produce that.
I wouldn't call deadlock, but this kind of a physical limitations will be reached in terms of mission time and the weight of the battery as the drones get bigger and the longer mission times required.
So what is the perspective for export market?
Actually, we feel that it has a good chance to be exported, this PG50S. As a coincidence, just today, just before this interview, a local drone producer just contacted us and asked about this engine and its capabilities because they felt that they reached the battery power limit, battery powered drone size limit, if you will, with the electric power drive systems. So we feel that it's a good market because as drones get bigger and longer mission times, they will need fossil fuel powered engine power.
We see at the same booth the TS 100, 1400 engine, turboshaft engine for the Gökbey helicopter.
Yes.
We heard that it passed the expected minimum requirements.
Yes.
1570, as far as I know, the horsepower, shaft horsepower. And so what is the test process? When we will see it integrated on the helicopter?
Actually, as you might also know, we delivered our very first prototype more than a year ago for integration, platform integration work to start at TUSAŞ, Turkish Aerospace. That work already started. So after that, we also keep testing our engine to mature, to complete the maturization cycle, as well as the certification process. There are different types of tests required for certification. Currently, we are working with the Turkish Civil Aviation Authority for certification process, and we have completed many tests. So far, we pushed our engine up to 1570 horsepower. The significance of this power is, let me give some details about why this power is significant. The engine name, as the name implies, is of 1400 horsepower, comes from the fact that it is the continuous maximum power the engine can deliver. Of course, it is at sea level. Everything, all the power numbers we discuss about, translated to sea level power to compare it apple to apple.
Because it is universal.
It's a universal standard. So our engine is designed to deliver continuous 1400 horsepower, which we demonstrated it way earlier. Then during takeoff, it is supposed to give, it is required to give 1475 horsepower during takeoff, additional 75 horsepower, which we also demonstrated in testing. And 1570 comes as the emergency takeoff horsepower. What is this? It's a 2-minute excessive power requirement required in the testing, in the certification for this engine. It is required such that there might be an emergency case that you may have to take off with additional payload, human or whatever. If this aircraft is used in, for example, Department of Forestry, there's a forest fire, and the firefighters somehow, because of the change in the wind direction, they were left within the fire itself, and they have to be evacuated immediately to save their lives. So you go in there with a helicopter, you take them out. So when you go there, you find out there is more.
You need more energy, more trust.
There are more people than you can take off. I mean, they say your helicopter limit is 10 people, and there are 12 people there. You cannot say, no, I cannot take you. I mean, it is leaving them to death. So what you do, this is called emergency case. You leave all the excess weight, even you dump some excess fuel, and you have to take this additional load and human load and take off. And this requires, this is called emergency 2-minute takeoff. And your engines, they are supposed to give you extra power, 1570 horsepower for 2 minutes. This is a requirement. So we reached this power level during our testing, and not only 2 minutes, we tested for much more multiples of 2 minutes. Like I believe we tested about 30 minutes. So we passed this threshold as well. In terms of the date, you asked of when we see
on the
human flight. of course, there are more tests to be completed with the engine before we receive the certificate, even before we receive the first manned flight authorization. I mean, we can test this engine, different conditions, but Civil Aviation Authority should give us the authorization to fly with a human. So we expect this to happen within a year.
Within a year.
Within a year.
I see.
There are still more tests to be done.
As it is the same class of thrust, do you think that this engine could be used at attack engines, attack helicopters as well? Do you, if you had to, do you think that there is a capacity in Turkey to work on FADEC, which is one of the most important crucial parts of the previous engine?
The current engine is developed for Gökbey, and Gökbey is a dual-use, quote-unquote, dual-use helicopter. So engine is also being certified as dual-use, civil and military. But of course, attack helicopter is a pure military application, and they have additional requirements. The TS 1400 is the same power range, power class engine that is capable of delivering the sufficient power for attack helicopter as well. But to meet the other additional military requirements, there should be some additional work to be done on this engine, which is not a big work. We can develop a military version of this engine in a short time. But currently our first duty is to complete the first application and fly it with a human powered flight in a Gökbey. After that we can work on this for additional derivative engines.
There is Attack 2 coming up, which requires 2,000 horsepower.
More than 2,000.
More than 2,000.
3,000.
3, sorry. I was thinking about 3, I said 2. I was thinking about your Sikorsky T-70 engine suddenly. The first 14 engines they are expected from Ukraine to come. And very recently we heard that Russia hit the factory where the engines are produced. So do you think that you will take part in this project, or is there any work to provide the required engine to Attack 2 helicopter?
Actually, we have been contacted about this engine need by Turkish aerospace company, our parent company. So we know their need, and we currently have an internal work to produce, to design some bigger horsepower core engines up to like even beyond 3,000 horsepower. But this is still in early work, and of course we need some official project and funding to develop the full engine. But we have some internal work already started towards that application.
So if they say start, here is the fund, let's start. How long do you think that it will require for you?
Actually, for first prototype, I believe it can be done like about 3 to 4 years, a first prototype. But because it will be again a human carrying engine, there will be still some certification long process. Certification process takes long to mature the engine to be mature enough so that the human life can be trusted.
Sure. We see Akıncı outside.
Yes.
And we know that TEI provides engine for TB3. And what is the situation for Akıncı? Do you have any work for them?
Actually, we have a new project with the Presidents of Defense Industries for 225 horsepower version of the PD-170 engine class, diesel engine class. We already started the work on that. Currently, we reached the 225 horsepower, and we are in the further maturization and testing process. And
this is for TB3.
For the TB3, not for TB3, for Akıncı.
Akıncı, okay.
Akıncı requires even more horsepower. So 225 horsepower is for Akıncı, not for TB3. TB3 is currently we already delivered PD170 and they are working on the integration. For Akıncı, they require more power. So we developed this PD222, 222, and it will deliver 225 horsepower. We already developed the engine. We are in the testing and maturization process. And as of now, we completed more than 70% of the EASA CSE 440 requirements, life requirements, long-term durability life testing ongoing, and we completed more than 70% of it.
We see TEI mostly only on aviation engines, but Turkey has for the Navy many projects going on, and there will be a new coming up, for example, TF-2000 for air defense destroyer, and there could be some smaller projects as well. Could we expect TEI to take part in the future on such projects?
Of course. Actually, there are two parts of this question. One, currently, the Turkish developed Milgem ship class, Navy battleship class. They have LM2500 GE General Electric engines, as you know. And currently we are negotiating with GE to get the license for AITM or maintenance and repair and overhaul capability, because as Turkey uses more and more of these engines, Turkey needs local repair capability and
overhaul capability.
The manufacturer also acknowledges that. So we are negotiating with GE and we announced that either IDEF last year that we already signed a protocol, MOU, that we'll be working together with GE to develop this capability in TEI in Turkey. So that work is ongoing. And as we speak, TEI is currently producing some parts of the complex parts of these LM2500s in Turkey as well. We are producing some parts of this engine. The other part you ask, like, will there be any engine TEI will be developing for the LM application, land and marine applications? Yes, it's possible. If you go to bigger power class, like for Attack 2 helicopters, if that program becomes an actual project, funded project, if you develop a 3,000, 4,000 horsepower shaft power helicopter engine with some minor modifications, you can develop a LM derivative of that engine, which can be used in ships. Of course, these are still small engines when you consider the marine applications, but still it depends on this Attack 2 helicopter program. It can be considered in one package.
Mr. Akşit, thank you very much for answering our questions.
Thank you.